Hello friends, this is Professor Himanshu Deshmukh. So today we are going to see problems based on friction dynamics. Now we know what is dynamics. Dynamics means a certain body when it is in motion, we say that that body is in dynamic condition. There is another condition known as static condition in which the body is at rest. Okay. So in this case we will study when the body is in dynamic condition, what happens. Okay. So let us begin our today's question. The question says an automobile of mass 1.2 tons moves down a 5-degree incline at a speed of 50 km per hour. When the brakes are applied, causing a constant braking force of 5 kN. Determine the distance travelled by the automobile as it comes to rest. Okay, so this is our basic question. So in short, what is our question is telling us is that there is a certain automobile. Okay, automobile you can consider any car or heavy vehicle. Okay, whose mass is 1.2 ton. Okay, so now this automobile is moving at a moving on an inclined surface. Okay, so suppose we can say that there is an inclined surface. Okay. Now this inclined surface is at an angle of 5 degree. Okay, so this angle is 5 degree, and there is a automobile here. Okay, so suppose this is an automobile. This automobile is moving down this inclined surface which is at an angle of 5 degrees Celsius. Okay, now the weight is or the mass is 1.2 ton. Okay, and it is moving down a 5-degree incline. Okay, it is moving down on this surface which is inclined at 5-degree angle. Okay. Now the speed of this automobile is 50 km per hour. Okay, it is moving with a speed of 50 km per hour. Now at this speed, this vehicle is applying a brake. Okay, it is applying a brake and causing a constant braking force of 5 kN. Okay, so what is the braking force that this automobile is applying? It is 5 kN. Okay, and what you have to determine the distance travelled by the automobile as it comes to rest. Now since this automobile is applying brake, it will come to rest after covering a certain distance. Okay, so suppose say after covering suppose from here to here. Okay, this automobile reaches here, and at this state it is becoming rest. Okay, at this point it is moving with a speed of 50 km per hour. Okay, and after covering this distance is shown by S. So after covering S distance, this vehicle comes at rest. Okay, now why this vehicle is coming on rest? Because it is applying a braking force of 5 kN. It is applying basically brakes. Okay, now what you have to determine? You have to determine that after how much distance, that means after how much value of S, this vehicle will come to rest. Okay, so this is our basic question. So first let us write down the given conditions. Initially the mass is given, it is 1.2 tons. So 1.2 into 1000 is kilograms, because 1 ton is equal to 1000 kg. Okay, so 1.2 tons will become 1200 kg. Okay, now moves down a 5-degree incline. So angle theta is given, it is 5 degree. This angle is given 5 degree at a speed of 50 km per hour. Okay, now see what is the initial speed of this automobile. It is 50 km per hour, and what will be the final speed of this automobile? Since it is coming at rest, so final velocity will be 0, right? It will be 0. So initial is 50, final is 0. Now we know that initial velocity is written by u. Okay, it is 50 km per hour. So it is into in kilometer per hour. We'll convert it into meter per second by multiplying by 5 upon 80. So it will become 13.889. This will be meter per second. Okay. Now when the brakes are applied, causing a constant braking force of 5 kN. So what is this 5 kN braking force? Okay, now since this vehicle is applying a braking force, that means because of this braking force there will be frictional force which is occurring between this surface and the surface of vehicle. Okay, so this braking force 5 kN is nothing but the frictional force. Okay, so F is also given, it is 5 kN, that means 5000 Newton. Okay. Determine the distance travelled by the automobile. So what you have to determine? S. Okay, you have to determine S, and also it is coming at rest, that means the final velocity will be V and it is equal to 0. Okay, initial is U which is 50 km per hour and final is V which is 0. So these are the given conditions. So let us first draw the Fbd of automobile. Okay, so for drawing Fbd I have considered this vehicle to be a square box. Okay, and we all know how to draw this free body diagram. Okay, so let us see which are the forces which are acting. So initially this is the body in the form of block which is on an inclined surface which is inclined at an angle of 5 degrees Celsius. Okay, now there are certain basic forces which are acting. The weight of the object will be acting in downward direction, so that will be W. Okay, now see, the mass is given and here the acting force will be W. So W is nothing but m into g. M is 1200 into g is 9.8, so the weight will become 11,760 Newton. Okay, so this is the weight of the organ. And what is the mass? Mass is 1200 kg. Okay, it is given here. This is mass and this is weight. Okay, now opposite to weight is the reaction force. So this is the reaction force. Okay, this is not the reaction force. Actually, reaction force will be perpendicular to the surface. Okay, so that is the reaction force. Okay, now weight is over, reaction force is over. Okay, now we know that this vehicle is coming down on this particular surface. So what will be the motion? It will be in downward direction. Now opposite to motion is the frictional force. Okay, so the frictional force will be this towards left. Since motion is towards right, frictional force will be towards left. It is 5000 Newton. Okay, now this weight which is acting vertically downward can be resolved into two components. Okay, we know that since this angle is 5 degree, this angle will be also 5 degree, and if this angle is 5 degree, this component will be cos component. Okay, so it will be W cos 5. Okay, and what is W? It is 1160. Okay, so this will be 11,760 cos 5. Okay, and this will be 11,760 sin 5. Okay, so we are done with weight, the reaction force, and also the frictional force. Now there will be no any other force which is acting in this particular object. Okay, so this completes our free body diagram of automobile. Understand friends that the directions of these forces are very important. Okay, frictional force is always opposite to the direction of motion. So first you have to determine which is the direction of motion. Opposite to that motion is your frictional force. Okay, and if we resolve this weight in two components, okay, these will be the directions of weight. Okay, now for solving such problems which involve dynamics, you have to use this particular principle, D'Alembert's principle. Okay, now what is D'Alembert's principle? It is summation of F minus MA is equal to 0. Remember this formula friends. Okay, now D'Alembert's principle is nothing but it is simply based on Newton's second law. Okay, now what is Newton's second law? We know Newton's second law is F is equal to MA. This is Newton's second law. Okay, so if we take MA left side, it will be F minus MA is equal to 0. Okay, it is one and the same. So it is summation of F minus MA is equal to 0. Okay, now understand what is summation F. Now summation F means summation of all the forces. Okay, but which forces? The forces which are causing the motion of this particular object. Since this object is moving in downward direction, okay, it will move in downward direction because of the horizontal forces. Okay, so these are the two forces, the weight component and the frictional force. These are the two components which are causing the motion of this particular block. Okay, so what will be summation F? Summation F will be the forces which are causing the motion of this particular block on the inclined surface, all the horizontal forces. Okay, so it is nothing but summation of all the horizontal forces. Remember friends, there is this reaction force, but this reaction force is vertically upward and weight is vertically downward. So both these forces are cancelling out each other. Okay, so because these forces are cancelling out each other, so this body is in equilibrium in the vertical direction. Okay, it is in equilibrium in the vertical direction. That is why it is not moving in the vertical direction. It is moving only in the horizontal direction. And why it is moving in the horizontal direction? Because of these two forces. Okay, so these are the forces which are causing the motion of this object, and in this case only the horizontal forces are causing the motion, not the vertical forces. Okay, so this will be summation of F, that is horizontal forces, minus MA is equal to 0. Okay, now what is summation of horizontal forces? There are two horizontal forces. This is going towards right, this is going towards left. Okay, so this will be plus, this will be minus. So it will be 11,760 sin 5 degree minus 5,000. Okay, this MA I have taken towards right. So it will be, what is M? M, we know that M is 1200 kg. Okay, so it is 1200 into acceleration is unknown, so it will be A. Okay, so this will become 1024.95 minus 5000 is equal to 1200 A. Okay, so if we simplify this, it will become minus 3975.048 is equal to 1200 A. So the value of A will be equal to minus 3975 this upon this. Okay, so the value of acceleration comes out to be minus 3.313. Since it is acceleration, it will be in meter per second square. Okay, so by calculating or by considering D'Alembert's principle, we have found out the value of acceleration. It comes out to be minus 3.313 meter per second square. Okay, now remember what we have to find out. We have to find out the value of s. Okay, and how what you have found out till now? You have found out the value of acceleration. Okay, now since this this acceleration is in negative. Okay, now what does this represent? That the acceleration is reducing. It is retardation. Okay, opposite to that of the acceleration. Okay, so this negative sign represents retardation. That means the speed is reducing, the acceleration is reducing. Okay, now we have to find out the value of s. Okay, and since this is a dynamic state, now in dynamic state you have to use the laws of motion. Okay, so let us see which equation we can use. So using kinematic relation, v square is equal to u square plus 2as. Okay, so from this equation we can easily find out the value of s. Okay, now see there are other two equations also. For example, v is equal to u plus at. Okay, that you have, but in that case there is time involved, and in this entire numerical there is no relation of any time. Okay, so we'll use this equation, v square is equal to u square plus 2as. Now value of v, we know it is 0, and value of u is 13.889. Okay, so substituting all those values, v is 0, u is 13.889 square plus 2 into a is minus 3.313 into s. Okay, now in this equation there is only one unknown s. Okay, so we can easily solve this equation and find out the value of s. So the value of s comes out to be 29.11. And what is s? S is the distance covered. Okay, it is the distance covered. So the unit will be meters. So the value of s comes out to be 29.11 meter. Okay, so this is how you solve numerical which is based on dynamics. So in this case also, this case is of friction. Okay, but this friction is causing in dynamic state. So, and in dynamic state we use the laws of motion, D'Alembert's principle, and by using such principles and such formulas we can find out what is being asked in the numerical. Okay, so I hope you have understood this numerical. Try to solve more such numericals and let me know in the comment section. Thank you.